Hey guys, Mr. Backerberg here. In this video, we're going to take a look at radian measures. So the radian measure of an angle that is located at the center of the unit circle is equal to the length of the arc that the angle itself intersects on that circle. And we typically use Greek letters to represent our angles. So this theta here along this red arc is representing the distance that this angle is intersecting on that circle. So whatever that distance is would be the radian measure. And there's a direct correlation between a radian measure and a degree measure. So if we want to convert an angle from radians into degrees, then we're going to multiply by 180 degrees over pi. But if we want to go the opposite direction and go from degrees into radians, we're going to take whatever our degree measure is and multiply by pi over 180 degrees. So in this first example, we're going to look at doing a few conversions from degrees into radians. And these are all going to be important angles that we need to be comfortable working with. So in part A here, we're going to convert 30 degrees into radians. So if we want to convert a degree angle into radians, we're supposed to multiply by pi over 180. Well, if we multiply those together, we're going to get 30 pi over 180, but we want to look at reducing down that 30 over 180, and that's going to reduce down to being pi over 6. So that means that 30 degrees in radians is pi over 6. If we look at converting 90 degrees into radians, we're going to do something similar. So taking 90 degrees and multiplying by pi over 180. We're going to end up getting 90 pi over 180. Reducing down the 90 and the 180, we're going to get pi over 2. So a 90 degree angle is the same as pi over 2 in radians. Last one we're going to do here is converting 180 degrees into radians. So if I take 180 times pi over 180, I get 180 pi over 180, and those 180s are going to cancel each other out, so we just get pi. So 180 degrees is the same as pi in radians. In this example, we're going to be working the opposite direction, so going from radians into degrees, and first we're going to convert 2 pi over 3 into degrees. So to convert a radian angle into degrees, we multiply by 180 over pi. I notice that there's a pi on top and on bottom that we can cancel out. 2 times 180 is 360 over 3, and then 360 divided by 3 is 120 degrees. So 2 pi over 3 is 120 degrees. Taking a look at this next one, we're going to convert 11 pi over 6 into degrees. So 11 pi over 6 times 180 over pi. Pi's on top and on bottom cancel each other out. 11 times 180 is 1,980 over 6. And then if we divide that out, we're going to get 330 degrees. So 11 pi over 6 is the same as 330 degrees. Last one we've got here is 3 pi over 2. So taking 3 pi over 2, multiplying by 180 over pi. The pi's are going to cancel each other out. 3 times 180 is 540 divided by 2. Dividing those out, we end up getting 270 degrees. So 3 pi over 2 is the same as 270 degrees. In this example, we're going to be finding an arc length. So we're going to find the length of an arc on a circle with a radius of 3 and a central angle of 120 degrees. So I'm going to draw a picture of what's happening here. We've got a circle, and we've got a 120 degree angle in the middle, and the radius of our circle is 3. And we're trying to find the length of this arc that our angle is intersecting. Now, we just talked about a radian measure being the length of an arc intercepted by a central angle on a unit circle, so a circle with a radius of 1 unit. Well, this circle has a radius of 3 units, not quite 1 unit. but there is still a connection to what we know about radian angles. There's a formula for finding arc length that says S equals R theta, where S is the arc length, R is the radius, and theta is the angle, but measured in radians. So if we want to find this arc length, we're going to take S equals the length of the radius, which is 3. Then we're going to multiply by our angle, but we need it to be in radians. So 120 degrees, if we want to convert that over into radians, we're going to have to multiply by pi over 180. So we get 120 pi over 180. 120 over 180 reduces down to 2/3. So we get 2 pi over 3. That times 3 and that divided by 3 are going to cancel each other out. So we get an arc length of 2 pi. Now, as far as a decimal approximation, if we wanted to multiply that out, we could. Pi is about 3.14, so 2 times 3.14 would be about 6.28 approximately. So as we're looking at our 6 trig functions, when we've got an angle theta graphed out in standard position, the 6 basic trig functions are defined as follows. So we've got the sine being the y value from the coordinate over the length of the radius. If you're dealing with a unit circle where the radius is 1, then the sine is just your y value from the ordered pair. The cosine of theta is the x value from the ordered pair divided by the radius. Again, if you're dealing with a unit circle where the radius is just 1, then the cosine is just the x value from the ordered pair. Tangent is y divided by x. The radius is not involved there, just the ordered pair. But then we've also got reciprocal trig functions as well. So the cosecant is r over the y value, so that's the reciprocal of the sine. Secant is the reciprocal of the cosine, so r over x. And cotangent is the reciprocal of tangent, x over y. One last thing to note, when you do trig in calculus, you're always going to do it in radian mode, unless the specific problem or example or whatever it is that you're working on states otherwise. That's going to be it for this video. Thanks for watching.